Welcome to our channel Circuits Analytica. In this video, we will discuss a tutorial on mesh analysis. For the following network, find current flow through 2 ohms resistance and 5 ohms resistance. First step is to mark the loops as loop 1, 2 and 3 as shown in the diagram. Then mark the mesh currents as I1, I2 and I3. So according to our notations, current flow through 2 ohms resistance is equal to I3 and current flow through 5 ohms resistance is equal to I1 minus I2. So we are asked to find I3 and I1 minus I2. As I3 is the current flow through 2 ohms resistance and I1 minus I2 is the current flow through 5 ohms resistor. According to Ohm's law, we can write V2 is equal to 2 into I3. V5 is equal to 5 into I1 minus I2. V3P is equal to 3 into I1 minus I3 and V3Q is equal to 3 into I2. Apply KVL for loop 1. So here in this loop, 212 voltage source is considered first. Moving in the clockwise direction from negative to positive, so 212 should be taken as positive. Next term in the loop is voltage drop across 3 ohms resistance V3P. Moving in the clockwise direction as we are going from positive potential to negative potential, V3P should be taken as negative. Next term in the loop is V5. Moving in the clockwise direction, as we are moving from positive potential to negative potential, V5 also should be taken as negative. So according to KVL, we can write plus 212 minus V3P minus V5 is equal to 0. So taking negative symbol outside, plus 212 minus inside bracket V3P plus V5 is equal to 0. Rearranging the terms, we can write V3P plus V5 is equal to 212. According to Ohm's law, V3P is equal to 3I1 minus 3I3 and V5 is equal to 5I1 minus 5I2. Therefore, we can write 3I1 minus 3I3 plus 5I1 minus 5I2 is equal to 212. Rearranging the terms, we will get 8I1 minus 5I2 minus 3I3 is equal to 212, equation number 1. Apply KVL for the second loop. In second loop, there are 3 voltage terms: voltage drop across 5 ohms resistor, voltage drop across 3 ohms resistor V3Q, and the applied voltage of value 122 volt. So moving in the clockwise direction, let us consider 122 volt first. So in the clockwise direction, as we move from positive potential to negative potential, 122 should be taken as negative, so minus 122. Considering voltage drop across 5 ohms resistance, moving in the clockwise direction as we move from negative potential to positive potential, V5 should be taken as positive, so plus V5. When we consider the third voltage term, voltage drop across 3 ohms resistance V3Q, As we move from positive potential to negative potential, V3Q should be taken as negative minus V3Q is equal to 0. So rearranging the terms, we will get V5 minus V3Q minus 122 is equal to 0, or V5 minus V3Q is equal to 122. V3Q is equal to 3I2 and V5 is equal to 5I1 minus 5I2. Application of Ohm's law. So applying KVL in loop 2, we will get 5I1 minus 5I2 minus 3I2 is equal to 122. 5I1 minus 8I2 minus 0I3 is equal to 122. Equation number 2. Applying KVL for the third loop. In the third loop, there are only two voltage terms. Voltage drop across 2 ohms resistance V2 and voltage drop across 3 ohms resistance V3P. Moving in the clockwise direction. When we consider voltage drop across 2 ohms resistance as we move from positive potential to negative potential, V2 should be taken as negative minus V2. When we consider voltage drop across 3 ohms resistance V3P, as we move from negative potential to positive potential, V3P should be taken as positive. So plus V3P is equal to 0. V3P minus V2 is equal to 0. According to Ohm's law, V3P is equal to 3 into I1 minus I3 and V2 is equal to 2 into I3. Therefore, we can write 3I1 minus 3I3 minus 2I3 is equal to 0. 3I1 minus 0I2 minus 5I3 is equal to 0. Equation number 3. So now we have three equations. 8I1 minus 5I2 minus 3I3 is equal to 212. Equation number 1. 5I1 minus 8I2 minus 0I3 is equal to 122. Equation number 2. 3I1 minus 0I2 minus 5I3 is equal to 0. Equation number 3. Solving the above equations, we will get I1 is equal to 44.15 ampere, I2 is equal to 12.35 ampere and I3 is equal to 26.49 ampere. So current flow through 2 ohms resistance is I3, which is equal to 26.49 ampere. And current flow through 5 ohms resistance is given as I1 minus I2, which is equal to 31.81 ampere. So current flow through 2 ohms resistor is 26.49 ampere and current flow through 5 ohms resistor is 31.81 ampere. Thanks for watching Circuits Analytica. Enjoy learning. Please comment, like, share and subscribe our channel.